Welcome back. So now we're on the back side of our notes for probability day 2. So now that we know how to use the formula, we know what factorial is, now we're going to apply it so that you know which formula to use. Now I talked about how permutations order matters, and with combinations it doesn't. So when you read the problem, you have to figure it out. So let's look at number 5. How many ways can 5 people line up? Okay, when you're lining up, that means that order matters. So that means it has to be permutations. Let's look at these other two here. 4 people are chosen out of a group of 10 for a study. How many ways can this be done? So it's 4 people that are chosen out of a group. So basically, because you're just picking 4 people, you're picking a group of 4. So order does not matter. And because it doesn't matter, it's NCR. It's a combination. Okay. And then on this one, how many 3 women and 2 men committees can be formed? So this is also a group, which means order doesn't matter. So it's NCR, it's combinations. So part of the problem is figuring out which formula do I use. So I hope that by highlighting this and kind of talking about that, it's been made clear to you. So on this one, you have 5 people, and you want 5 of them in line. So you're putting all 5 of them in line. So it's 5p5. So then you just put it in your formula: 5 factorial, 5 minus 5 factorial. And then something to keep in mind, definition. 0 factorial is defined to be 1. It's a definition. So whenever you see 0 factorial, you know it's just 1. So I have 5 times 4 times 3 times 2 times 1 over 1. And when you do this enough times, you kind of memorize some basic ones. So 5 factorial is 120. So 120 possible ways for 5 people to line up if you want to keep writing a sentence. On this one, 4 people are chosen out of a group of 10. So 10 is how many you have, and you're picking a group of 4. So 10C4. So this is where you're going to do 10 factorial over 10 minus 4 factorial, and then 4 factorial. So 10 minus 4 factorial is 6 factorial. So I'm going to do 10, 9, 8, 7, and then 6 factorial. And then 4, 3, 2, 1. So those cancel. So I just get out my calculator. I'll show you how to do this on your calculator without writing everything out. So 10 times 9 times 8 times 7 is 5040. And then 4 times 3 is 12 times 2 is 24. So that divided by 24 is 210. Okay? All right, let me show you how to do this on your calculator so we don't have to do all of the factorials for number 7 because it's a little bit annoying. So on your calculator, you can use the math button, and then you go to the PRB, or sometimes there's a PRB button on your calculator, and then there should be an NPR option or an NCR option. So let's do 5p5 on our calculator and get 120 without having to do all the factorials. So PRB. So notice when I do that, it says answer NPR. That's because you need to put the first number down before you do that. So 5. It's going to be like that on your scientific calculators with the PRB button. So when you do that, you get 120. And then you don't have to do all the factorial stuff, okay? And then with combinations, it's the same thing. If I want to do 10C4, I do 10, and then I go to the PRB, whoops, a little shadow there, and then down to the NCR, and then 4, and that gives me 210. So you can do it on your calculator without having to do all the factorial stuff. Okay, for this one, I have 12 women that I'm picking 3 from. So 12 choose 3. And then I have 8 men that I'm picking 2 from. And you're going to multiply both of those. The other way is the 12C3 times 8C2. Okay, so you can write it either way. It doesn't matter. So I'm going to do this on my calculator. I'm going to do 12C3 on my calculator. Then I'm going to do 8C2 on my calculator. And then I'm going to multiply them. Okay, so 12. You can do all the factorial stuff too if you don't have. Most calculators have these buttons though. So that gives me 220 for the first one. And then 8C2 gives me 28. So then 28 times 220 gives me 6160 ways. Okay, so when you have different groups that you're doing, you take each of the combinations and you multiply them together. Okay, so now we're going to use this to do probability. So remember, with probability, you want favorable over total. Okay, that's how you find all probability. So with these, we're going to be doing the same idea, but using combinations. So let's take a look at this. There's 9 songs on the playlist. 4 of them are country and 5 are pop. With a random shuffle and no repetition, you listen to 4 songs. What's the probability that you listen to all country? So, what you want to do is you want to have the possible ways to choose 4 country out of 4 country. And then on the bottom, you're going to want the possible ways to choose 4 songs out of 9 songs total. Okay, so the favorable is that all of them are country. So you have 4 country songs, the number of ways that you can pick all of them. Okay, and then on the bottom, it's how many ways you can pick 4 songs out of all 9. So on the top, it's going to be 4 choose 4. And on the bottom, it's going to be 9 choose 4. Or you can do the little parentheses notation. It's the same thing. Okay, so I'm going to do these on my calculator. So 4 choose 4. I already know that's going to be 1. And then 9 choose 4. So much better with the calculator, huh? It's so quick. Now with probability, usually we like percents. So this is going to give us 0.0079, which is about 0.8% when you move the decimal 2 places. All right. So why don't you try number 2 and 3? Well, let's do 2 together, and then you can try 3 on your own because it's more similar to that. So in this problem, we have a shipment of 15 smartphones, and 9 of them have cracked screens. We want to know what the probability is that exactly 5 of the first 7 sold are cracked. Okay, so that means I want 5 cracked, and if there's 5 cracked, how many are not cracked? If you're picking 7, 2. Right? And then on the bottom, because you're picking 7 phones. Okay, so on the bottom, it's the total, which is 7 phones out of 15. And here it's the 5 cracked out of the 9 that are cracked. and 2 that are not cracked, right? Out of the 6. Okay. Let's see. Exactly 5 of the first 7 sold. Yep. So 5 of them are cracked. 2 are not cracked. Okay. So we have 9 C5, which is out of the 9 with cracks. You want 5 to be cracked, right? And then there's 7. So that means there's 2 left that you're picking out of the 6 that are not cracked. So if 9 of the 15 are cracked, 6 are not cracked. Okay, because 9 plus 6 equals the 15 phones, right? So that's how we got all that. Then on the bottom, 15C7. So how many ways you can get 7 phones at all? And then on the top, it's more specific about cracked versus not cracked. And when we have 2 combinations, we multiply them. Okay, so I'm going to do this on my calculator. So 9 C5 is 126. And then 6 C2 is 15. And then, last but not least, whoa, big number. 126 times 15 is 1890 over my denominator. And like I said, we like decimals so that we can then make them into percents. So this is going to give me 0.2937, which is basically 29.4%. All right, go ahead and pause the video and try this last one to make sure you understand, and then start it up again so you can see. Okay, welcome back. So this one says you are dealt 5 cards from a deck. What's the probability that you will have 2 kings? So you want to have 2 kings out of 4 kings that are possible. And then if you have 2 kings on a deck, that means that you have 48 left. You want 3, because you're doing 5 cards. So 3 non-kings, right, of the 48 non-king cards. And then on the bottom, it's just how many ways you can pick 5 out of 52 cards. Okay, so I have 4 kings. I want to choose 2. I'm going to do this with my other notation here. And then 52 minus 4 is 48. So out of the 48 that are left, I want 3 to be non-kings over how many ways you can just do 5 cards out of 52. Okay, so when you do this on your calculator, this gives you a 6. This one gives you that. Big numbers. So when you multiply that and do it on your calculator, you should get about 4%. So hopefully that's what you got. All right. Hopefully that all made sense. Thanks. Bye.